Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Catalytic hydrogenation of an alkyne with excess H2 over PDC or similar catalyst converts the CC triple bond to AC, C single bond, adding to hydrogen atoms across the triple bond. The carbon skeleton connectivity of the alkyne is preserved, only the degree of unsaturation changes. Therefore, any alkyne that has the same carbon skeleton as 3-ethylhexane will yield 3-ethylhexane upon complete hydrogenation. Moving on to the next step. Determine the structure of 3-ethylhexane. 3-ethylhexane has a hexane main chain, 6 carbons, with an ethyl substituent at C3. Total carbons is equal to 8. Skeleton CH3, CH2CH, CH2CH3, CH2CH2, CH3. Moving on to the next step. Any alkyne that gives 3-ethylhexane must have the same 8-carbon branched skeleton, differing only in having a CC triple bond somewhere in that skeleton instead of a C single bond. And for the final step, analyze each option. A. The structure shown is a terminal alkyne, HCC, attached to C3 of a branched chain with an ethyl group, consistent with 3-ethylhex, 1-ene. Hydrogenation gives 3-ethylhexane. B. The structure shown is an alkyne with the triple bond in a different position on the same 3-ethylhexane skeleton, example, 3-ethylhex, 4-ene or similar. Hydrogenation gives 3-ethylhexane. C. The structure shown is another positional isomer of the alkyne on the same skeleton, triple bond near terminus with ethyl branch. Hydrogenation gives 3-ethylhexane. Since all three alkynes, A, B, and C, share the same carbon skeleton as 3-ethylhexane and differ only in the position of the triple bond, all three yield 3-ethylhexane upon catalytic hydrogenation. Therefore, the correct answer is D. Therefore, the correct answer is option D.